What's going on, ladies and gents? Welcome back to a brand new video. Today's video is a big one. Today I'm going to be breaking down my final project as a Masters of Architecture student. I'm going to be breaking down everything from head to toe. This is going to be a full comprehensive breakdown of my Masters of Architecture, final project that got me my Masters of Architecture degree. So yeah, sit back, relax and enjoy. Just before we dive into the video, please just hit that subscribe button. I think we're very close to 30,000 subscribers, so please just hit the subscribe button. That would be absolutely great. And also smash the thumbs up button as well if you enjoyed this video. We're going to go into some proper detail today, so yeah, without further ado, let's dive into it. Okay, so welcome to transport, the logistics market. The reason why I actually chose the word transport is because my project is on a port, and it is a distributions facility for perishable goods. So there's that kind of transportation of goods. And so I called it transport, just a bit of play on words, basically. I actually did a poll on my Instagram on the weeks leading up to my submission. And I had such an amazing response of basically people giving me ideas of different names for the project. And yeah, it was really kind of an interesting thing to do. And eventually I basically decided on transport logistics market. And as you can tell, the front page is a pretty bold and kind of in-your-face drawing. And that is what I really wanted to do with the front page, is to give you a really strong inclination of the style of the work, the style of the drawings, the graphic communication that you're going to expect throughout the project, but also a bit of an insight into what the project is without showing too much. So you could look at this and you could think, okay, I don't have a clue what's going on here. But you kind of get the gist of it. There's some bold contrasting colors. There's this kind of sharp language of geometries. And then you go into the contents page, and once again, it's a similar thing. It's a graphic drawing that just kind of gives you an idea of the style of stuff to come without giving too much away. And then the research portion of the project begins. So at the University of Westminster, the Masters of Architecture program is 2 years long. And in second year, the year is broken down into two portfolios, the design portfolios. So portfolio one is essentially kind of tailored towards research, understanding your site, and just doing a kind of intensive research into a particular topic. And then portfolio two is more kind of realizing that research into an architectural proposal. So this brief is the first brief that we got for the year, as you can see, brief 1A, and it's called Picturing Time. So in my studio, which is DS23, we are basically encouraged to do a research into movement and understanding movement through photography and film. So this brief was called Picturing Time, and it basically looks into the work of Etienne Jules Murray and also Edward Muybridge, who were basically people who studied movement and analysed movement through photography. So the first task we were given was to capture a type of movement. So we had the choice of either doing a nature movement, a human and animal type movement, or a mechanical movement. And of course, I went for a mechanical movement because I thought that would be the most interesting and the most compelling, and you get some really cool drawings out of it. So the mechanical movement that I decided to analyze was tower cranes. And the reason why I chose tower cranes is because I think they're actually really quite interesting. When you're in London and you're immersed and living in London, you see tower cranes all of the time. And so I was just kind of infatuated by them, and I thought it would be a good opportunity to create some cool mechanical drawings, and they're also quite accessible to be able to go and film them. So this is a drawing that basically just digests what a tower crane is and what we were kind of going to research and analyze with this mechanical movement, which led me into my analysis of the mechanical movement. So this is a 5-minute clip of two tower cranes in operation. They're working on the same building site, so they're kind of working in unison as a system. And basically what I began to do was to try and understand the movement geometries of this crane to be able to extract some kind of movement. So with this task, once we had the film and the capturing of the movement, we were basically encouraged to be able to abstract that movement and extract bits and bobs from the movement to be able to get some kind of expressive reinterpretation of the movement through our kind of drawings and on our analysis. So what I did was very quite strategic. I wanted it to kind of make sense and be quite logical. So what I did was I broke down the video into individual keyframes. So these are keyframes every 7.5 seconds, because obviously cranes don't really move that much. they're quite slow, obviously. I had to basically emphasize the movement. And so I kind of created big gaps between the frames. And I basically just picked up on the points of movement from the crane and tracked the movement. So this is creating some kind of geometry based on the points of movement of the crane. And this is an abstraction from that analysis. This is basically just a timeline which I've put the frames on in chronological order and connected them, which kind of creates these kind of abstract movements. And then further, I wanted to basically understand the movement and the movement in space, because obviously a lot of this analysis currently is looking at it in 2 dimensions, looking at it from the photo. And so I wanted to understand what the movement was like in plan and what the movement was like in space. So by overlapping groups of frames, so from frames 1 to 5, 6 to 10, 11 to 15, etc., I overlapped the movements and I began to track the movement in plan, so the rotations in plan and the rotations in space, which came to this drawing that basically demonstrates the movement of the crane over the 5-minute period in this drawing here. So this is a perspective drawing, and then this is an elevation and plan. And so here you get some kind of really simple abstraction and expression of this movement of the crane over the 5-minute period, and extracting the movement away from the thing that it actually is. And from that point, the next brief was to basically express those kind of movements and those drawings, abstractions into models. And so I created this concept model that very, very simply expresses this movement path of the crane over the 5-minute period, and with 2 arms which kind of look and meant to be representative of crane arms. And I did it in frame 1 to frame 40, and basically you can see the movement path between the frames. And then in more detail, I wanted to create something a little bit more complex that expresses the kind of tectonics of the crane. And so I created this abstraction of the model. All of the framing coordinates are expressed on the base as these weights move up and down, the arms move up and down. The movement path is obviously expressed with the red line again. And as you can see here, this is just expressing some details of the hinges and the rotations and the actual kind of tectonics of a crane. So that is looking at a mechanical movement in some kind of detail, some really, really precise detail that is expressing it through some kind of abstraction and be able to use models and drawings to extract that information from the film to be able to express a movement study. So then brief 2 came about. So once we'd kind of spent several weeks exploring the nature of movement and the formal and spatial opportunities that it offers, we basically then went into our site, which was Antwerp, and basically looking at the potential of the basis of our projects. So the logic going into Antwerp was basically to try and understand, based on the movement that you had analysed, what you could then go into Antwerp and take some kind of research out of that might link to your movement study. And so heading into the site, we were basically thinking about the opportunities of our projects. As you can see here, we've got this really cool 360-degree photo of the studio. And during our trip of Antwerp, we did a series of 3D scans of various spaces and objects that we came across. 3D scanning the spaces was a great way of documenting the spaces that we visited, which we could eventually use as 3D digital models. The app that allows you to document really high quality 3D scans is Polycam, and I have found this to be a great tool for documenting your project sites. Polycam uses a LiDAR sensor on your Apple device to scan any job site, project spaces or rooms in a matter of seconds and creates professional looking 3D models and floor plans. Whilst on your site visit, you can use the LiDAR or room mode to scan the space, and the app lets you export your 3Ds into 10+ export formats, which is perfect for bringing your scans into software such as Revit, AutoCAD and Blender. I have particularly found their LiDAR mode to be very impressive with the level of detail it picks up. One of the most useful functionalities is their measure tool, which allows you to manually measure any distance or space and even automatically generating all the necessary measurements. It's a pretty good scan. This is a great tool for architecture students or architects. Thank you Polycam for sponsoring today's video. So when we began to start thinking about programmatic opportunities and potential site locations in Antwerp, I wanted to make a really kind of strategic and logical approach to this. So what I did was I kind of took a step back and looked at my previous body of work into mechanical movements. And so what I wanted to do was I wanted to create kind of a compelling narrative of mechanical movements throughout my project. I also understood that there's a series of micromechanical movements that kind of lend themselves together in a system of mechanical movements. So although the tower crane is a very, very small movement within a system of movements that are happening at different scales. And so throughout my research, I understood that Antwerp had a port. And so obviously within a port, there is a series of micro and macro movements that are working together as a system. And so I kind of saw this as an opportunity to link both my mechanical kind of micro movements of the tower cranes into potential research into the Antwerp port, which could lead to a potential project. And so what I wanted to do was look at mechanical movements at different scales. And so I decided to look into shipping movements and logistics at the world scale, Europe scale, and also an Antwerp scale. So by understanding the relationship of and the movement of vessels moving across the globe, I began to basically understand the relationship of Belgium and Antwerp with the globe and how important of a port it is for the import and export of goods. And also a really important thing that makes Antwerp such a big and important port in Europe is that it's got really strong rail freight corridor links with the hinterland connections around Europe, which means that Antwerp is the second largest port in Europe, and it is kind of a wide chosen port for the import of goods. And so this kind of made a logical step from going into I can't even speak. So this made a logical step going from my mechanical movements and going into these kind of really macro scale movements and then zooming back into the port. It was established in 1811, so it's pretty old now. It's got 17 terminals, 7 locks, and it's got it's pretty big. It's massive. And so that was obviously a bit of a challenge when coming to thinking about a design project. And so I zoomed into the port, looking at a particular container terminal, which is the MSC PSA European terminal, which is the largest container terminal in Europe. It is also huge. So this is basically just looking at the different types of movements and mechanical movements and the logistics that happen at a port level and also a yard level. And so this section here describes the different zones of the kind of working zones. So you've got the key area, you've got the transport area, you've got the yard area, you've got the transport area, and then you've got the truck and train area. And this is basically just trying to do some research and understanding of how the port works, and in particular how this particular container terminal works, and looking at these kind of micro movements all working together in unison. And at this point, it was quite vague research into kind of port logistics and kind of what happens on a port front in terms of the types of cranes and the different mechanical devices that are being used at the port front. And so I wanted to do a kind of bit more in-depth detail and research into a particular food chain that is being distributed and stored at the port. And so what I wanted to look at was perishable goods. And so I looked at the cold chain goods, which is an unbroken low temperature controlled supply chain network, which is basically just the network and the distribution of foods and liquids, goods that are going to perish. So you can also have medicine in there as well. And so during my research into perishable goods, I basically understood that Antwerp don't have many facilities for perishable goods. And this obviously then kind of sparked a bit of, they don't have much perishable goods facilities. However, they've got a second largest port in Europe. Why do they not have perishable goods facilities? And do they have a distribution center for perishable goods? And they don't, for example. And so that kind of really kind of triggered my interest into perishable goods. And so I kind of delved quite deep into perishable goods to understand where the locations are, where the facilities are, where the cold storages are. And I understood that there is only 4 cold storage facilities in Belgium, and there's one in Antwerp, but it's not on the port front, it is off the port. And the rest are kind of dotted around Belgium at quite a distance. For example, this is 50 kilometers away. This is 200 kilometers away. And I basically saw this as an opportunity to design a perishable goods distribution facility on the port front, literally right on the port. And so what I did was I did some research into perishable goods factories and distribution facilities. So I visited this perishable goods factory, which was a Tesco manufacturing warehouse. So this basically just taught me the amount of pallets that they'll be able to store the different types of temperature control zones, the types of storage systems that they use, the types of conveyor belt systems and racking systems that they use, and also how they basically, the kind of logic of goods coming in, goods being unloaded, goods being stored, and then goods being distributed and exported. And so this was a really useful kind of site visit for me, which leads me into my project proposal. So into the project proposal, as I've just explained, the project program is a perishable goods distribution facility, but it also collides with retail buying and consumption of goods. So what I wanted to do was basically develop a project that expressed all of these mechanical movements, obviously was a perishable goods distribution facility, but I also wanted it to have some kind of community value that is going to bring value to the city of Antwerp. So one thing that I noticed whilst being in Antwerp is that there was a very clear disconnect between the port and the city, obviously for security reasons, for safety reasons, for privacy reasons, because obviously you can't really get people to the front of the port, and being with cranes and containers and everything, it's quite a kind of complicated system. And so I wanted to basically bridge that gap in a safe, secure, and obviously kind of maintaining the privacy of the port. So I basically decided to combine these different logics of spaces. So combine a distribution facility with retail markets, with restaurants. And so the point of this is that you would have people coming into the port to experience the distribution of goods, the movements, the different mechanical movements, but they would also experience their goods being imported into Antwerp, and they could even watch the goods being packaged, they could watch the goods being distributed, and they could also eat the goods on site as well. So you've got this kind of idea of that you're bringing people into an earlier stage of the logistics process, you're bringing them into the port, you're bringing them into the building to be able to watch goods being consumed and be able to be distributed. Because within the logistics process, as you saw with the perishable goods facilities across Belgium, is that often when goods are imported into Antwerp, they're distributed across Belgium to be stored before they're then transported back to supermarkets across Antwerp. And so the idea is that you're bringing people into an earlier stage of that kind of distribution, which means that they'll get fresher goods. The goods will obviously be kind of more efficient. You'd have a kind of a faster load of goods coming in and out. And you kind of got all of these kind of juxtaposition of spaces that create this kind of really interesting project, and this kind of collision of spaces. So that was the logic. It sounds quite complicated, but in reality, it's actually quite simple. So the idea is that you've got a distribution facility, you've got retail markets and restaurants all in one building. And so obviously, thinking of something quite high tech and complicated, I wanted to look into certain precedents. So looking at different types of systems, and also conveyor belt systems, because I thought it'd be really interesting to introduce these kind of conveyor belts of goods, because it kind of makes it a really kind of experiential thing for people visiting the port. They can come and see all of these goods being moved around on conveyor belts. And then obviously looking at Ocado, which uses automated systems and package systems to distribute goods. And so looking more into detail into the chosen site, my site was huge, of course, because if I'm doing a distribution facility, I want it to be pretty big. I want it to be pretty bold. And I also wanted to use the existing system and network of the port. And that was a really big thing for me because I didn't want to disrupt the port. I wanted to use their existing infrastructure. And so I used their existing rail network. I used a Sea Invest terminal, which is a container terminal. I wanted to use the existing rail network, views over the surrounding ports, and also road access for visitors. And that came to creating a kind of design logic for my project. And so if you've kind of seen some of my work previously, I'm very much inspired by this kind of harsh geometry and kind of sharp edges, kind of like Daniel Libeskind, Zaha Hadid type constructivist type stuff. And so obviously I was going to run with that with this project because I kind of like that style, and that is a graphic style that I like to design with. But obviously I wanted to develop my project based on the context of the port. And so what I did was I developed a system using the existing grid system of the port. So picking up on various existing buildings, picking up on the waterline and the boundary of the port, picking up on the rail network, which basically allowed me to have this grid system which I used to create geometry, but also break in the grid at the same time. And this kind of helped me create some kind of language. And this obviously wasn't just kind of random picking and choosing of kind of geometry and overlapping of spaces. I picked up on some of these precedent studies. Zaha Hadid Peak Club was a really important one. And this is basically a project where Zaha used distinct rectangles to overlap to create moments of clashing spaces. And you also get this kind of language of things rotating and these objects rotating, which is obviously this very kind of constructivist style. And so as you've got these spaces overlapping, you create pockets of solids of voids. And in perspective, you can see that some of these voids are floating, some of them are above each other, some of them are clashing. And this was the kind of design logic that I wanted to go with for this project. And then you've also got the BMW Central Building, which is a warehouse. It's the BMW warehouse factory, sorry. And here you've got these kind of cantilevered, but also kind of conveyor belt systems that are clashing with an office space. But whilst you're in the office space, you've got these kind of cars going through, which is this kind of juxtaposition of spaces that I wanted to express within my project as well. And then finally, you've got some Enrique Morales. Of course, a lot of my work is inspired by Enrique Morales and his kind of geometry that he generates. And he also uses a lot of these kind of hinges and these rotations of spaces. And this building is basically designed off a fan. So you've got these kind of rotating spaces that they overlap and creates these kind of large voids underneath, and these kind of opportunistic spots. So these were all the kind of design logics that I picked up on. And I used that grid system from the port to be able to create this kind of changing language where you've got this shifting geometries, overlapping of spaces. And the reason why I wanted these clashing and overlapping of spaces is because I wanted to express the clashing of distribution, the clashing of retail markets and the clashing of restaurants. And you've got this kind of language that is kind of emphasizing this collision of spaces, but they're also integrated. And the reason why I have these really long spaces is because I've got the warehouses that run parallel to the port. So you've got the goods coming in and going through the warehouse. And then you've got these kind of expressive restaurants and retail markets that break through the warehouses. So it's the kind of this metaphor of you and the people entering the warehouse and breaking the kind of logistics process by being introduced earlier into the process. And you've got this kind of expressive language of these spaces colliding. And so it's quite a kind of a metaphor in that case. And the reason why these are so long is because typically in warehouse and manufacturing spaces, they're designed obviously in rows because they have the different temperature controlled environments. And so what I did here was I broke the building into 3 long linear components to express 3 different temperature controlled environments. So in these different spaces, you would have different environments that would store different types of perishable goods. And this kind of just plays with the logic of manufacturing spaces and warehouse design. And once again here, you can see the clashing of planes. And I've also got a kind of development sketch archive that kind of describes all of this thinking. Which leads me to some more kind of expression of the geometry. So I made this model kind of to tie in with my early mechanical movement stuff, using the same kind of colors and materiality and logic and kind of style, but also trying to also kind of express this constructivist inspired project that has these linear components through which represent the warehouses, but then you've got these retail markets that break through. And so you've kind of got this abstract model that expresses the geometry and the kind of design logic of the building. And this is just a really simple model that I put together. I actually vlogged me making this model, so if you want to see that, I'd definitely check it out. But this is just a really useful drawing model to tie in my movement studies with my design project, both graphically and obviously logically at the same time. Which leads me into my final drawings, and this is where it kind of all comes to life. So obviously a lot of what I've explained has been very kind of abstract, expressive stuff that you might have got lost in, which I got lost in for a bit whilst designing this project. But now when you kind of look at these drawings and the visualizations of the project, it all kind of comes alive and you're like, oh, okay, it makes sense. Well, hopefully anyway, I hope that's kind of how you feel as you kind of go through these. So this is a context view of the port. As you can see, the building here that is picking up on the geometry of the container yard. And as you can see here, you've got these long stints and this expressive stuff that is clashing through. And this is just the building in context. And this is the site plan. So the site plan, once again, tries to express the kind of grid and the logic of the existing container yard, but also shows the kind of expressive language of the building. Even though the building is actually very simply designed based on the grid structure, it also has quite expressive components that are quite visual when you're looking at it from above. And so this is the building. This is basically the entrance, the public entrance you could drive in. These are car parks for the public. You've got car parks for the workers of the warehouse, and then you've got private exit zones for all the containers, and obviously keeping a consistent kind of route for the containers to come and go as they please. And then this is a drawing that once again kind of ties into the mechanical analysis and abstraction, and this is basically just showing the logic and the building and site strategy for my project in a kind of abstract way. So this is the boat coming in. This is the containers being unloaded. This is the truck bringing the containers to the building. The containers being unloaded into pallets, then unloaded into punnets that are then packaged, that are then put back into pallets, that are then put back into containers to be distributed. So although that sounds kind of confusing, but that is the kind of simple logic of a manufacturing perishable goods warehouse. It's really actually quite simple. Goods are being imported, the pallets are taken out of the containers, the pallets are broken down into punnets to then be packaged, to then be put back into pallets, then be put back into containers, to then be distributed across Antwerp, essentially. And this is another visual here that shows transport in context. Then we go into the floor plans. So these floor plans, as you can tell, are quite a large scale, and you can kind of start to see the kind of workings going on inside the building. But on the ground level, you can see goods would be imported in these spaces. These are called temporary storage zones, where you would store the goods, the pallets of goods, within, I don't know, half a day. You would then go into the cold storage zones where the pallets are stored for a longer period of time, usually kind of 3 days maximum. And then you've got the conveyor belt systems that are packing all the goods into packets to be then stored again to then be distributed across Antwerp. And as you can see here with the design logic, you've got these public markets breaking through the building. And so in these spaces where you're breaking through, you can see down and look down into the lower conveyor belt systems to be able to get this kind of immersive experience of the distribution of goods. So as you can see here, this is the full section of the building. This demonstrates the goods being unloaded into the project, goods being imported and brought down into pallets, which are then obviously moved around using automated systems. And as you can see here in the section, you can see how big the spaces are, see how small that person is. And then you can see this clashing of spaces here. And then going into the packing zone, you can see all of the conveyor belts are emphasized in red. And I've kind of put all of these automated robotic arms in to express the kind of high-tech distribution of goods and packing of goods. And so you can see the conveyor belts that run through and that are packing up all of these are strawberries here that are being packed up. And up here you can see these balconies from the public spaces that are looking down, and you can kind of experience these spaces below. And then you've got the public entrance, which as you can see here is really kind of emphasized by this contrasting geometry between the two and this kind of poking, the public zone poking through. And so you've got this kind of escalator that goes up, and then you've got this ramped space that runs all the way up the building, which has basically retail markets either side. So the point of this is that when goods are imported and packaged, some of the conveyor belts will obviously, well, most of them will go through into these storage zones, but some of the conveyor belts will go up and basically provide goods into the market stalls above. And so whilst you're buying goods, you've got goods coming through on conveyor belts, and you've got this really kind of juxtaposition of spaces where all this stuff is kind of going on. And so as you can see here, this is a slope that runs up with market stalls on each side, and then you've got eating zones here with views over the port to be able to watch the import of goods. And so as you can see here, these are the goods, the market stalls. So as the goods are being brought in by the conveyor belts, they're sold to the public. So the public come and buy really fresh goods. Some of the goods are obviously cooked and made into some kind of meal. And then you've got eating zones with views over the port. And then this is a section here that demonstrates this kind of collision of spaces. You've got the storage zones, and then you've got these packing zones with conveyor belts that are going up into these spaces. And you've got this really weird kind of juxtaposition of being sat eating goods whilst watching goods being imported. And you can see here all of the conveyor belts are in red, and you've got this kind of collision of spaces with views over the port. And then this is a view looking down into the packing zone. So this is a view of someone kind of stood on the balcony looking in, and you can kind of see all of these goods kind of being packaged and being moved around. And once again, this is kind of like an abstraction drawing that emphasizes these collision of spaces. And you can also kind of start to see the structure of the building. So the kind of, I'll get into that in a minute actually. And then you've got the top floor, which is the restaurant, and the restaurant has panoramic views over the port. But the actual restaurant itself is designed based on kind of Yo Sushi conveyor belt inspired restaurant, which basically obviously continues the analysis or the kind of the language of the building using conveyor belts and these mechanical movements in this high-tech system. And so you've actually got conveyor belts of goods that are bringing goods around, obviously that are being cooked in the restaurant, which then leads into the structure of the building. And I created a full technical report that describes the structure of the building. And so I only included a little bit into my design portfolio because obviously it's a design portfolio and you want to include a lot of your kind of design work. But basically the building is broken up into two different types of materials. So I've designed the kind of continuous warehouse structure based on steel trusses. And the reason why I picked steel trusses is because obviously it's a really good material structurally for warehouses, and it's obviously a very well used material, but also you can use them, you can reuse them for future warehouses or future structures. And then the building, the spaces that cut through the building are basically built with timber. So you've got this kind of juxtaposition both on the types of spaces and the language, but also on the materiality. And this just expressed some of the kind of the solar shading to be able to keep the internal spaces cool, and some of the kind of cold storage systems that I'm using, and also some of the rain harvesting and other kind of UV panels that I'm using for the roof, and basically kind of my sustainable design decisions. And this just expresses the reuse of the steel structure. So this just demonstrates the steel structure being dismantled, being loaded onto a boat, being transported to a new site via boat, and erected as a new structure for future use. And then this here just demonstrates the kind of another kind of contrasting design between the warehouses and the retail markets, is that in the warehouses I've designed this horizontal facade system, but on the retail markets I've designed a vertical timber cladding system. So you've got this also juxtaposition between the two facades, and this expresses how these kind of components come together from a timber point of view. The timber is the building is made out of LVL, laminated veneer lumber, And that is the project. And I'll finish up on another abstract drawing that really kind of just expresses the graphic style more than anything. And that is my project. That is my Masters of Architecture project, my degree project that I've worked on for the past year, or the past 9 months since September. I really hope that kind of gives you a really good idea on the project, and it gives a really comprehensive breakdown of the project and the briefs and basically the thinking behind all of the stuff that we were doing. For the past year, I've been struggling to try and explain the work because it's quite complicated and there's a lot of kind of moving components, moving parts. And I didn't really want to have to explain it before it was completely done, and then I could really go into detail and express exactly what I was thinking, why it is the way it is, and some of the kind of design decisions and logic behind it. So thank you so much for watching today's video. If you enjoyed it, please smash that thumbs up button. That'd be much appreciated. Make sure to subscribe, hit that notification bell, and I will see you next time.